Algebra video 2 for lesson 9.1. It says now how can you use a table to find the solutions of x squared minus 7x plus 6 equals 0. So we're going to focus on tables now. We're still going to use Desmos. So let's go into Desmos. And what we're going to do is we're going to type in this function, right? So again, think of it as the related function f of x equals x squared minus 7x plus 6, okay? And then the gear button here, you can take this function and see this little table thing, you can convert it to a table. I just found this out online. And there it is. There is the table that represents this function. Now, it only gives you the standard -2 to 2 values, but we can keep typing more values in. But notice the y's. We're looking for where y is 0, right? Because the original equation was x squared minus 7x, plus 6 equals 0. We're looking for the x values that makes the function 0 when y is 0. So I see right here, right? So one of my solutions, one of my x-intercepts is 1, 0. So x equals 1 is one of my solutions. Okay. Now, if you notice here, if we look at the y's and how they're changing, so the y's are going down, down. So down to 14, down to 6, down to 0. So they keep going down, down, down. So I'm going to continue going in this direction. I'm going to make my next value 3. Okay, still going down. 4. Repeated value 5. Now we're growing. So what this means is that somewhere in here is the vertex, right? This parabola opens up. So we have this situation here, and you can see that the vertex is right here, right around 4, right? A little bit before 4, or a little bit before 4. So now, if we keep going, so let me type in 6, and there we go. There's my second answer, 6, 0. So 6, 0 is another intercept, and x equals 6 is a solution. Now I suppose I should, hide that graph from you. It won't let me. Thought I could hide the graph. There you go. Right, hide the graph from you. So we're just using a table. But anyway, you can see on the graph. There we go. If I zoom out 1, like I like to, that's x equals 1, and that's x equals 6. And there's your two solutions. Okay, next one. All right, so now it says how can you use the table to estimate. So now we're going to use a table and we're going to estimate the solutions. And here's our function. Again, we're going to graph the related function f of x equals 3x squared plus 5x minus 2 because it is set equal to 0. And then we'll look at the table to see when that does come out to be 0. All right, so back to Desmos. I'm going to clear this. I'm going to change this function to 3x squared plus 5x minus 2. Okay, so I have the graph turned off because I don't want to cheat, right? We'll look at it at the end, okay? And then I'm going to come down here. I'm going to come here, say gear. Yes, I want to add a table, convert to a table, and again, let's hide that. Okay, good. There we go. Okay, so right off the bat, we have one of our solutions. One of our solutions is -2, 0, right? Because we're looking for when this equals 0. That's the y value. There we go. So -2, 0 will be an x-intercept, and x equals -2. Sorry about the double negatives. X equals -2 is an answer. So now we're looking for the next one. Now look at these y values closely. So it goes from 0 down to -4, but notice here it goes up from -4 to -2. So if we're going down and then we turn back up, somewhere in here, let me not do a circle there, let me arrow. Somewhere in here I think is going to be the vertex, okay? And now to find the other solution, now we need to see when, as you look here, -2 to 6, when do these signs change? -2 to 6, right? So if we're at 0, -2, and we go to 1, 6, notice that to connect those, we have to cross the x-axis. That means that another solution is going to be somewhere in between 0 and 1, because somewhere in between here is going to be a y value of 0. So now you'll notice on my table, I'm going to start using smaller values in between 0 and 1. So if we have 0 and 1, I'm going to go 0.5 in the middle, 0.25, and 0.75. I'm going to type these values in as my x's and see what the y's are and see how close I can get to being 0. Okay? So let me clear my, so you'll see. So 0.25. Okay? So that's negative 0.526. And what I can do is, I'll do one better. I'll actually insert it here where I need to. Not there. Here. There we go. So 0.25. Okay. I'm going to type in the next one. So I'm still negative. I'm looking for a return positive, 0.5. And there, look, I turned positive. So you see that in this interval here, between 0.25 and 0.5, we went from negative to positive. So that means our second solution is somewhere in here. So our first solution is x equals negative 2. But our second solution is between x between 0.25 and 0.5. So again, we're just estimating. We're not finding the exact value. And now if I turn the graph back on, here's the dots. You can see there's your vertex somewhere between -1 and between -1 and 0, like we talked about, right? And then you can see that this other x-intercept right there is at 0.33, and that would be in between 0.25 and 0.5. All right, last problem to go. A little word problem. Let's take a look at it back in our notes. All right, the problem says Anastasia hits her golf ball off the tee. The height of the golf ball is modeled by the function f of x equals -5x squared plus 25x plus 1, where x is the number of seconds after the ball is hit. How long is the golf ball in the air? I'm going to slide this over here so we can take a look at the graph. So we are going to use Desmos. We're going to put this into Desmos and then just talk about it. Now, first off, notice that my quadrant is just the first quadrant because this is a word problem, right? X needs to be greater than or equal to 0. It's time, right? It's time. Now, if we want to see how long the ball is in the air, right? When the ball stops being in the air, it hits the ground, right? So when the height equals 0, we're done. So that's basically what we're saying. When does the height become 0? When does it hit the ground, right? Think of this x-axis as the ground. Okay. All right, so let's go ahead and go to Desmos, and that's the word ground. That's terrible. Ground. All right, let's go to Desmos. Let's graph this. Okay. So it says -5x squared. Now I know it's going to go down, and again, think about how a golf ball travels, up and then down, plus 25x plus 1. And again, I'm going to zoom just on the first quadrant. Notice that my x's, right, there's not very many, okay? So, but my y goes kind of high. So I'm going to zoom out one time. Okay, so there's my picture. I'm actually going to change, and this is more than you need to do, right? I'm going to leave the y the same, but I'm going to change the x's from -1 to, let's say, 10. Right, so I can see a better picture. There we go. Right, just looks better. Okay, I'm going to graph that on my paper. Important points are 0, 1, the y-intercept. Notice where the ball's hit from. The vertex, 2.5, 32.25, and then this point right here, 5.040. I'm going to graph those 3 points. And again, just have to sketch it. Not a huge deal. Don't have to use these. I'm not even going to use these marks. I don't know. So, okay. All right. So this is, again, I'm not going to use the marks. So that's 0, 1. Then I have to go back. Sorry, I wasn't paying enough attention. 2.5, 32.25. So again, not using the coordinate 0, 1, 2.5. So I'll say let this be, let's count, I don't know, Let that be 1, let that be 2, 3, 4, 5. So 2.5, 32.5, so we'll say right around there. So that point is 2.5, 32.5, something like that, or 0.5, whatever it was. And then 5.040. And there's the picture of your curve, right? Opening down. That's terrible. Try better. So again, please pardon my terrible parabola, but that's the picture. And again, it just wants to know when it's going to hit the air again. Notice that again, if we want to know when it hits, how long it's in the air. So when the height is 0, that's the same thing as saying when y is 0. That's just this x-axis. Now notice, because it was hit from a t 1 foot or 1, I don't know, a t is not a foot, an inch maybe, 1 inch above the ground, I don't know. So that's not going to have an x-intercept on the left. That counts, because the x-intercept will be over here, negative time land. That's not going to count. But here, right, here, this is when it hits the ground again. This is how long it's in the air for, 5.04 seconds. Right? And there we go. That's what we're looking for, the other x-intercept. And again, that's why Desmos is so powerful, but we will soon learn other methods of solving these. Okay, thanks for watching 9-1, and we'll see you in class.